Dear friends, welcome to my channel. Now let us see some illustrative examples on scalars and vectors. My name is Johannes, so let us see basic examples on scalars and vectors. So example 1.1, let us see dot product and cross product. So find the angle between two vectors A 4i plus 2j minus 2k and vector B again 3i plus 2j plus 3k. So you have ijk and also determine A cross B. So using the formula of dot product, now let us see the solution. It is clear and straightforward. A dot B is given by this one, A component, which is AX, AY, and AZ. Then dot with BXI, BYJ plus BZK. Then you can just multiply A with B, you can multiply. Again, A with B, you can multiply. Then I dot J will be cancelled out. I with dot K cancel out. Then you remain with this one. So I dot I is 1. Then it goes on like that. So we will have AX, BX. For the first AX, BX, you have again for Y component, AY, BY. Then finally, you have AZ, BZ. So BZ. So you have just you can multiply now. AX we have here AX. Then BX you have here 4 times 3. You have 12. The same is true for Y and J. Then you have for Y and Z component. You will multiply. Then finally you have this. So this is the dot product of the two vectors. And then you can find the angle between the two vectors. So the angle between the two vectors can be found from this equation, which is cos theta is equal to A dot B divided by the magnitude of individual vectors. A magnitude dot with multiplied with B magnitude. So you can multiply, just A magnitude will be under radical of AX, AY square plus AZ square. Then finally, you can have 4 square plus 2 square minus 2 square. Then you have 4.899. Again, for B magnitude, you can multiply. Just you can use this equation, BX square, BY square plus BZ square. Then finally, you can arrive for 22. Then finally, you have this result. Then you simply substitute the values. A dot B, you have 10 divided by 4.899 multiplied by 4.69, then cos inverse theta to get theta here, cos inverse of 10 over 22.976. Then this is the angle between the two vectors. Then you can find again A cross B. A cross B is also, you have this multiplication. You just simply, you can use this one as a determinant. This is just plus, then minus, then plus. Then to get coefficient of y, you just circle this one. You circle this, then you multiply AY BZ minus AZ by BY. So you can see here. Then again to calculate J coefficient, just you circle this one. Then you just multiply the other components. The other components will be multiplied. So you have this one AX multiplied with BZ, which is this one, then you can have you can make a minus here if you multiply AX BZ. Otherwise, you can reverse this one, no problem. So you have AZ BX minus AX BZ. Then you should put plus. Otherwise, you can reverse this one with minus sign. So plus for this component again, for Z component, just you will, the coefficient of K will be, you just circle this one, then AX multiplied by BY, you see, then minus AY times BX, coefficient of K. Then you substitute all the values, known values in each expression. Then finally, you get, this is the cross product of the two vectors. Then finally, A cross B magnitude can be found. So A cross B, which is 10 square plus minus 18 square plus 2 square and radical. then you get this is the magnitude of A cross B. Then the angle between the two vectors, you can find sine theta is equal to the magnitude of A cross B over the magnitude of each vectors and multiplied by the unit vector in the direction of the cross product of the two vectors. You can just see this one with just to check the angle between the two vectors. Okay, example 1.2 is just the line of action of 34 force runs through the points A and B as shown below. So you have one point here, which is this one, and point B is this one with coordinates A -7, -2, and point B is 8, 6. Then you have magnitude. Then determine the x and y scalar components of f and write f in vector form. So let us see. First, you have to designate these coordinates as x1, y1, and x2, y2. Let us see as a solution. You have x1, y1, -7, -2, which is the initial point. Then the terminal point is this one, which is x2, y2. Then you can find just slope, which is just this angle. You can find the angle at this point, which is very important. So sine theta, which is m. M is the inclination of this force, tan theta, or change in y, vertical difference divided by horizontal run. So you can have y2 minus y1 over x2 minus x1 is equal to 6 minus -2, which is negative. You have then 8 minus -7, then you get 8 over 15. Then theta can be computed now. The inclination angle, which is tan inverse of 8 over 15, then you found 28.07 degree. Then the scalar components of f will be, fx will be, which is f cos theta. So if you substitute f cos theta, then you found 30 kilometers. This is the x component, and the y component will be, you have f sine theta, then you can find this one, 15.998. Then in the vector form can be written as f vector will be 30i plus 15.998. So I think let us see using unit vector. Using unit vector, let us see. You have this equation. The force vector is equal to the magnitude of the force multiplied by the unit vector in the direction of the force, which is AB, in the direction of the force AB. Let us see. You have this equation, already we know. Just unit vector in the direction of AB is equal to AB over magnitude of AB. Then you have AB means just B minus A. So you have B coordinate 8 minus -7, which is x2 minus x1 I plus y2 minus y1 j over radical or magnitude of this AB, which is square this. Then finally you substitute the values. Then we get this is the unit vector in the direction of the force. So once we found, then you simply magnitude multiplied by unit vector. If you multiply, then you will find the same result, almost the same result with this one, with the scalar component, and we can use just this one. So I think this is nice. Then example 1.3 is an athlete walks 53.1 degrees north of east. Then for 2.5 kilometers. So you have distance. North of east, you have north of east. Then finally, then due east. Then he walks to east direction to this direction for 2 kilometers. What is his total displacement? What is his total displacement from his starting point? If you measure the distance along a straight line. So solution, first we draw the free body diagram of an athlete path, which is east of north, which is north of east. You have this angle measure, which is north of east with this degree measure, it's 3.1. Then after he walks 2.5 kilometers, again he walks with this kilometer. So I think this angle, we have this angle. Now let us see. let A be the first leg of the journey and B be the second leg of the journey. What we are looking for is the vector A plus B, which is the sum of this one, the displacement. So you have this one, then you have this one, then first you have this angle, which is the magnitude. AX will be magnitude of A, you have 2.5, then cos of this, which is this component, then you have 1.5 kilometer to X direction, AY again, sine of phi 1, which is 53.1, then 2 kilometer, then BX again, you have BX already, he walks horizontally, then B cos 0, already 2 kilometer is given to this direction, then you can have resultant. Resultant is A square plus B square minus 2 times magnitude of A, magnitude of B, cos theta. So cos theta. So you have to check this one, sin theta, which is cos theta. Sin theta is just sine 0, then 0 kilometer, which is for BY, just no Y direction, only horizontal, he walks. Then we will just use this one. Then you can calculate this P2. Then finally we arrive. So A plus B is AX plus BX plus comma AY plus BY. This is just the summation A plus B, which is 3.5 comma 2. Then finally you can find the displacement of so the distance from the starting point is given by Pythagorean theorem. For convenience, let C be the resultant vector, which is Cx square plus Cy square. Then finally, you just find this one. Then the angle of the resultant vector is just, you can find now, P2, which is tan inverse of Cy over Cx. Let me go back to this one. So you have, this is just the resultant vector. Then you have to compute this one. Already we have this walk. Then you have this one. Then we can calculate now. We can calculate. So Cx, which is 3.5, is the resultant. Cx, which is this one, Ax plus Bx, 3.5. Then finally, Ay plus By again, to Y direction. You can multiply. Then finally, the angle of the resultant vector is just tan inverse of Cy by Cx. Then tan inverse 2 over 3.5. Then this is the angle. Then you can find the resultant, which is the displacement is this one, so the resultant vector, or you can apply parallelogram method. Just you have this one, then you have to compute this angle. If you compute this angle, then you can find the resultant of these two vectors, or just you can use any sine law, this angle and this angle. Then finally you can find, because this magnitude is already known, you can find this resultant R. So you can just apply. So I think we can finalize using parallelogram law or law of cosines. So as exercise, you have two vectors have their scalar magnitude. You have A and B, while the angle between the two vectors is this one. Calculate the cross product of the two vectors. So we will apply the same approach. Then finally, we will use this one. 12 will be the cross product of the two vectors in the direction of n. So M1 initially walks northeast for this meter, then continues to walk east for 6.6 meter, and finally walks northwest for this dimension. Then before stopping, then determine the total displacement of the man. So you have this answer as a check. You can try. So let us see example 1.4. For the vectors b1 and b2 shown in the figure, determine the magnitude s, or just the sum of their vector, which is b1 plus b2. You have b1 and b2 with this angle measurement, 30 degree and 45 degree. Then determine the angle alpha between the vector sum and the positive x-axis. Again, write s as a vector in terms of the unit vectors I and j. Then you have just to compute, write a unit vector along n, along just unit vector n along the vector sum, which is b1 plus b2. Then let us see solution. We construct to scale the parallelogram shown just in fig next for adding b1 and b2 using law of cosines. We have this one s. So you have, I think, this angle we have. Then you can just draw. So the resultant may be like this. Then you can draw parallel to this one. You can draw. Then you have like this. Then you should compute this angle. This angle. Now just we will use cosine. So it will be 105 degrees. Then 5.59, which is the vector sum. Let us see the detail. Using law of sines for the lower triangle, which is this one. For the lower triangle, we have sine of 105 divided by 5.59, which is s, this one, equal to sine of alpha plus 30, alpha plus 30, this one, this angle. Then you have this one. This vector is, which is b1 for unit. Then sine alpha plus 30 is this one. Then alpha will be this one. Then you can find now, with the knowledge of both s and alpha, we can write the vector sum as this angle. Just I cos alpha plus j sine alpha with this s. Then finally, you can find this is just the answer, which is as a vector approach, you can write 5.43 I plus 1.328 j units. So this is just as a vector you can write, and the angle which is from the positive x-axis, which is alpha, which is the angle made by the vector sum with the positive x-axis, which is 13.76. And the unit vector in the direction of s vector divided by s magnitude, then this is the answer, which is the unit vector in the direction of s. Then the vector difference, again, you can follow v1 minus v2. So opposite to v2, since v2 is negative, so you will draw to this direction. Then you neglect this one. You will calculate along this one. So just 4 times I cos r 45, already angle is given, plus j sine 45. Then you will just put again for v2, you have this one, already angle is given, which is 30 degree. Then you will follow the same approach, which is just the vector d is shown, which is v1 plus negative of v2. Okay, another example is two forces are applied as shown to the bracket support. Determine graphically the magnitude and direction of the resultant using parallelogram and using triangle law. You have, this is the bracket, which is 800 pound is given from this one at 60 degree and 35 degree, which is 500 pound. So you will draw just the resultant r, which is going through this one. So with the positive x-axis alpha, we can say alpha. Then f1 is given, f2 is given. Then you have to compute this angle, which is first 60 plus 35 is, which is 95. I think 60 plus 35 is 95. So this angle is corresponding angle with this one equal 95. Then if we subtract 180 minus 95, it will be 85. So we will use this one as resultant calculation. Let us see resultant of using parallelogram law or cosine law. Square root of f1 square plus f2 square minus 2f1 f2, then f1 f2 cos of this one. So already we have cos of this angle. Already from 180 95 we subtract, then you have 85. Then the resultant is this pound. So using triangle law or sine law, f1 over sine of alpha plus 35. Sine of alpha plus 35 with f1. This angle. This angle is to f1 and this beta angle is to f2. Then this theta is to resultant. Then using sine law, again considering the lower triangle, f1 over sine alpha plus 35 is equal to r over sine of 85. Then you have this one again. Then we can take this as a calculation. F1 already know, resultant already know. Then we have sine alpha plus 35, which is this one. Then finally, alpha will be computed 26.63 degree. So r lies 26.6 degree from the positive x-axis, which is just shifting, and beta we can find 33.37 from 180, which is triangle. You subtract 26.63 minus 35.85. Then you can arrive at the solution. Then, as exercise, please try this one. Two forces P and Q are applied as shown at point A of a hook support, knowing that P is known and Q is known. So determine graphically the magnitude and direction of the resultant using parallelogram law and triangle law. So you can just draw. So you have the magnitude of P and Q, then you have resultant to some direction, you draw them. Finally, you arrive at the solution. Okay, so I think this is all about scalars and vectors. If you have any question or doubt, please forward. Thank you very much.